Okay, so in section 6.4, dealing with rational exponents, yesterday we talked about rewriting, going from radical notation to exponential notation. Right here was a just quick idea of what those two looked like. Right, 5 to the 5/6 power, that is written in exponential notation. We could rewrite that exact same thing in radical notation, saying the 6th root of 5 to the 5th power. Okay? So, expanding on that, we need to make sure that we know our properties of exponents. Because all rational exponents are just that, they're exponents. So all the rules that we learned for dealing with exponents still apply here. Okay, so all of these rules, if you're still not comfortable with these guys, then we need to get ourselves comfortable with those. You have to have them memorized. You have to know what those properties are for exponents, because they all still apply to rational exponents. Okay, we are now going to be simplifying expressions dealing with rational exponents. And a key thing, as you guys all hopefully remember, when we were dealing with radicals, we cannot have a radical in the denominator, right? No radicals in the denominator. Well, that still holds true, but now we're dealing with rational exponents. So, no rational exponents in the denominator. Meaning, if you have an x to the 1/2 in the denominator, you're going to have to rationalize that. You're going to have to get rid of that exponent of 1/2. And I'll show you how to do that. Something else is that you cannot have a fraction raised to a fraction exponent. Okay, and again, because that implies having a radical in the denominator. For example, let me show you quick. If I have 1/2 raised to the 1/3 power, using my rules of exponents, I know that this is 1 to the 1/3 power over 2 to the 1/3 power. Okay? And so that 2 to the 1/3 power means that I have the cubic root of 2 in the denominator. I can't have that, so I would have to rationalize that. Okay? And since I'm on it, I might as well show you real quick, how would I rationalize that? Well, first off, I would want to simplify anything I can. For example, I can take the cubic root of 1. What's the answer? 1. So I have 1 over 2 to the 1/3 power. I want to get rid of that exponent of 1/3. So I'm going to use my rule that says a to the m times a to the n gives me a to the m plus n power. And I want to multiply the top and bottom of this by 2 raised to a power.
2 over 3.
That's exactly it. I want it to be 2/3, because I want to take 1/3 plus 2/3 to get 3/3. And 3/3, of course, is 1. It goes away. Quick question.
So it's just like the thing we were doing when we had the radical?
It's exact same concept as the radical. That's exactly it. Yep. Same concept as with the radicals. So we now have 2/3 on top as well. So 2 to the 2/3 power. So this gives me 2 to the 2/3 power on top. On the bottom, I have 2 to the 1/3 plus 2/3 power, which, as you guys have already told me, is 3/3. And 3/3 is 1. So we have 2 to the 2/3 power over 2.
Can you cancel the 2's?
No, you cannot cancel the 2's, because that one on top is not really a 2. It's a cubic root of 2 squared. Okay? So we can't cancel the 2's. We would have to leave it like this. So let's look at some other examples here, and let's take a look at these rules real quick. Please remember, if you're multiplying items at the same base, you add the exponents. If you are taking a power and raising it to a power, you multiply the exponents. Okay, another one that we're going to run into a lot today is this guy over here. This one, we went through and basically thought of it as the definition of exponents. Okay, well today we're actually going to have to use that rule. Let me show you where. Right off to the side here, that first example. We have the 4th root of x to the 3rd power divided by the 8th root of x to the 2nd power. Now, one reason why we do rational exponents is that we are now able to work with these types of problems. So the first thing we should do is rewrite these as rational exponents. So we have x to the 3/4 power over x to the 2/8 power. Well, 2/8, that simplifies, doesn't it? Yeah. So that means I have x to the 3/4 power over x to the 1/4 power. Well, in the past, I said, hey, if we have x to the 5th over x cubed, think of that as just saying x times x times x times x times x over x times x times x. Remember, I didn't say actually write it out, but we thought of it that way. And we said, hey, these 3 x's on the bottom cancel with 3 x's on the top, giving us x squared. Well, we really can't do that anymore because I don't know how to write just x to the 1/4 power out like that. Okay, when you have fractional exponents, you can't do it that way. So what we actually have to do is we actually have to use the rule which says that we have x to the 3/4 minus 1/4 power. And it is always the top minus the bottom. I don't care if one's positive, one's negative. I don't care if one's bigger than the other. It's always the top minus the bottom. And so we have x to the, what is 3/4 minus 1/4? Well, but you guys are reducing it for me already. It's 2/4, which then we reduce to 1/2.
Why waste time? Write that. Why not just say...
Okay, let's try another example. Let's take a look at this first example A here. Okay? This seems like kind of an innocent problem. Okay, but actually there's a lot going on here, and there's a lot of steps to this that you're going to have to pay attention to.
Hey, where are we going?
Okay? First thing we have to do is we have to change 2.5 into an improper fraction. There are two ways of going about that. I could go through and say that I have 2.5 over 1. So now it's in a fraction form, but I still don't want decimals involved in my fractions. So to get rid of that decimal, I'm going to multiply the top and bottom here by 10. And so that gives me 25 over 10. And 25 over 10 can be simplified. 5 goes into both. 5 times and 2 times. And so I have 5/2. That is an acceptable way of changing that into an improper fraction. Okay? The other way that actually is my preferred method, but it takes the fact that you need to memorize what 0.5 is. So you have to have memorized that 0.5 is 1/2. And therefore, 2.5 equals 2 and 1/2. And now I can go through and use what I call the round of the world method, which I take 2 times 2, which is 4, and I take 4 plus 1, which is 5. Then I keep the original denominator, so I have 5/2. All right, I had that pause for a while. I apologize. So we have 16 to the negative 5/2 power now. We had to take care of that negative before we evaluate anything, so we put it to the denominator. So we now have 1 over 16 to the positive 5/2 power. And now the very important thing here is we have to rationalize our denominator. We cannot have fraction exponents in our denominator. And the reason for that is because fraction exponents are square roots, or cubic roots, or fifth roots. And we can't have roots in the denominator, right? So here's what we do. We look at the fraction. It's 5/2. Is 5 divisible by 2? No, that's why it's there. That's why it's not reduced, right? It's 5/2. Okay, we want to look for the next number larger than 5 that is divisible by 2. 6. The next number larger than 5 that's divisible by 2. That number is 6. So then, now that we know that, we want to look at the rule that says a to the m power times a to the n power is a to the m plus n power. We are going to multiply the top and bottom of this by 16 raised to some power. And we want to raise it to a power such that 5 halves plus something gives me 6 halves. It would be 1/2. So we have 16 to the 1/2 power over 16 to the 6 halves power, which is cubed, 16 cubed. Okay, so that looks innocent enough. We now have it rationalized. That's excellent. But you have to watch out when you're dealing with numbers. Dealing with exponents is almost easier than dealing with the numbers. Okay? Because we still have to pay close attention to what's going on here. For example, on the top, what does 16 to the 1/2 power actually mean? Square root of 16, which is 4. Okay? Now, in the denominator, I don't want to take 16 to the 3rd power. 16 times 16 times 16. That's a lot of work. That's not on your roots chart, right? But think in terms of exponents. How can I rewrite 16 using exponents?
4 to the square root of 2. Actually, yeah. 4
Using exponents, folks.
4 to the square root of 2. That's 16.
Okay, so on the denominator we have 16 to the 3rd power. We can rewrite 16 as 4 squared using exponents. So I have something to the 3rd power. That something is 4 squared. What do I do when I raise powers to powers? Powers to powers, I multiply them. So I now have 4 over 4 to the 6th power.
That's much easier.
That's much easier, but I'm still not done. I'm still not done because I have the same bases here, right? So let's take a look here. I could go through, and since this now, we don't have any fraction exponents, so I could go through and say, well, I've got 4 on top. It's going to cancel with one of the 4s on the bottom. Leaves me with 4 to the 5th power on the bottom.
But you want to get rid of it.
Or I could go through and use my rule that says I have 4 to the 1 minus 6th power, which is 4 to the negative 5th power. But the issue with that rule is I now need to worry about that negative exponent again. So I have 1 over 4 to the 5th. All right, we've got it all down to the bottom, except is this 4 to the 5th on our roots chart? Yes, so therefore I actually want you to evaluate it. What is 4 to the 5th power?
1024.
That is the answer. That is the simplified answer. If you have 16 to the negative 2.5 power, that is equal to 1 over 1024. Okay, let's try another example here. Let's take a look straight below it. We have this example A. Negative 8x square root of xy all raised to the 2/3 power. We want to simplify this down. First thing you need to identify is that you have things multiplied together raised to a power. So you are immediately using the rule, which is a product raised to a power rule. A times b raised to the m is equal to a to the m, b to the m, right? So in this case, we have 3 things multiplied together. A negative 8, an x, and then a square root of stuff. The square root comes together as a whole thing of itself, okay? So in rewriting this, I now have negative 8 to the 2/3 power. Why is that in parentheses? Why did I put that in parentheses? What do you think?
Because it's negative. And you don't
The negative has to go along for the ride, right? The negative was inside the parentheses at the beginning, so it still has to be inside the parentheses. Okay, the negative is also being raised to that 2/3 power. Times x to the 2/3 power times, now wait a minute, I don't want to deal with radicals. I want rational exponents. So I have xy raised to what power? Square root. How do I rewrite square root? 1/2 power. So xy to the 1/2 power then raised to the 2/3 power.
That's gonna be hard.
Mm-hmm. Okay, so rewrite the radical first, so it's xy raised to the 1/2 power.
You have parentheses inside of parentheses.
Yep. Okay, so now we have this. We need to evaluate -8 to the 2/3 power. Please remember, the denominator is the root, right? The denominator of the fraction is the root. So I have -8. I have the cubic root of -8. I have the cubic root of -8. What is the cubic root of -8? -2. So I have -2 squared. What's -2 squared? 4. -2 squared is 4. So we have now evaluated -8 to the 2/3 power. We still have x to the 2/3 power. Well, now we need to deal with that xy to the 1/2 raised to the 2/3. So we have a power raised to a power. What do? We multiply them. Power raised to a power, we multiply the exponents. So 1/2 times 2/3. 1/3. So we have xy to the 1/3 power. Well, now again, I have two things multiplied together raised to a power. So I need to raise each of those to that power. So I have x to the 1/3 power, y to the 1/3 power.
Can't you just do the x right now?
Now I can multiply my x's together.
So it would be x.
If I have the same base, what do I do to the exponents? Add them together. So I have 4x to the 3/2 power, 3/3 power, y to the 1/3 power. And you guys are already telling me that 3/3 is just 1. So I have 4x to the first power, y to the 1/3 power. 4 times x times y to the 1/3 power. You could also, and the book might write it this way, this is the answer I would be expecting. It is the same thing as if you had written 4x times the cubic root of y. Okay? They mean the same thing. All right, so one more example then would be example A right below this. For this example, we have two items inside the parenthesis that are being raised to a power. So I'm going to want to associate that power to each of those items, except that power is negative. I don't like working with negative exponents, so the first thing I would do is change that negative exponent to a positive exponent. And so I have 1 over 8x to the 15th power raised now to the positive 1/3 power. And now I can associate that 1/3 exponent to both items inside the parentheses. So I have 1 over 8 to the 1/3 power times x to the 15th raised to the 1/3 power. I need to evaluate 8 to the 1/3 power. So 8 to the 1/3 power is 2. So I have 1 over 2. And for x to the 15th raised to the 1/3, I have a power raised to a power, so I multiply those together. And 15 times 1/3 is 5. So I have x to the 5th power. That would then be my final answer. I am happy having exponents in the denominator as long as they're not negative, as long as I have no negative exponents, and as long as they're not fractions. I can't have fraction exponents in the denominator.